Just like the sine has an inverse, so does the cosine has an inverse again. And again, what the inverse was a reflection of the graph around the y equals x axis. So one way to think about that is you take the coordinates x and y, take those values and just switch them around. So the new x becomes the y and the new y becomes the x. And so that's one way to think about where are the inverses at and how to graph that. So let's look at our traditional cosine graph. Now remember, for it to have an inverse, it must pass a horizontal line test, and our cosine graph does not pass that if we look at its entire domain. So because of that, we must restrict the domain to a particular value, and we're going to choose restricting it from 0 to pi. So let's look at the cosine graph restricted from 0 to pi, and then find its inverse of that particular part. So let's look at 3 points, and we'll try to graph its inverse. 1 point we have is a point over 0 and up 1. So if we reflect those values, so rather than over 0 and up 1, we're going to go over 1 and up 0. So this point, its inverse point is that point right there. Another point that we have is over pi halves and up 0. So let's reflect that. So this time let's go up pi or over 0 and up pi halves. So I have a reflection. So this point and that point are inverses of each other. And the last point that we have over here is we have over pi and down -1. So let's find the inverse of that point. So over pi and down -1. This time it means let's go over -1 and up pi. And so those are the 3 points that we have reflected on the graph. And then what we can do is we can go ahead and sketch out its inverse. And so then there's the inverse of that particular graph. And then if we can barely see a little bit, and the graph is not exactly right, we kind of see a little bit of reflection on that y equals x axis to kind of see what that reflection graph looks like, or its inverse. Another point that we need to note here is that because we restricted its domain to find its inverse, we need to understand that its inverse must have values between -1 and +1. And so from that, we can begin to go ahead and find out some inverses. And again, what inverses are is we're going to have the cosine value. We want to know what's the angle that produced that particular value that we're giving. So one example that we have is the cosine inverse of -√3/2. So the question that we're asking is what value or what angle produced this cosine? And so the angle that produced that cosine was 5/6 pi. And again, that was one of the values that we've been trying to memorize, trying to understand. So it was just referring to that we had. Because remember, we are only looking at some very specific angles, 30 degrees, 60 degrees, 45 degrees, and so forth, and all its reciprocal angles around the circle. That we remember that if we had a value, a cosine of -√3/2, it produced an angle 5/6 pi. Or if we were asking, what's the cosine of 5/6 pi? The cosine of 5/6 pi is -3√2. And so that's how the inverses work with each other. Let's look at one more example. Nope. That was the last example that I had on that one.